Here's another test for convergence. The limit comparison test says that if you have two series with positive terms, and if you can show that this limit is a finite value greater than 0, then the two series that you used in your limit will both converge or both diverge. So the key to this test is to compare your given question to another series that you know the convergence or divergence of. If you evaluate this limit and get a finite value, you will then know the convergence or divergence of the other series. So again, check to be sure that your terms approach 0. Alright, so we want to use the limit comparison test. So the question here is to compare my given series terms to some other set of terms. And so I'm going to pick 1 over k squared. And I'm picking this because I know this is a converging p-series. And I know over here that if I ignored the 3 and the 1 and divided by the k, I'd have something over k squared. So it's kind of similar. Not exactly sure of that. So let's just see what happens if I do that. So I'm going to do the limit as k goes to infinity of one sequence divided compared with the other one. That simplifies as so, and now I'm going to evaluate my limit. As k is getting big, that won't matter, that won't matter. And so this is coming down to and so those will cancel out, and I will get 1/2. And I have a finite value, so I know that the convergence of this series and this series will be the same. That's what the limit comparison test says. And since I know that this converges, since it's a p-series with p greater than 1, so putting all this together, okay, mention what I showed. I showed that the limit and mention what I know about the other series that I chose converges therefore by the limit comparison test this series converges. Okay, another series, the terms approach 0 as k goes to 0. So I want to find a series to compare this to. I'm thinking of, if I ignore the root and I just think of the root of k squared, which is k, I'm thinking to compare to this. I know that this one diverges. So what I'm going to do is I'm going to do the limit of this over the given. And if I can show I get a finite value, then I know these two behave the same way in terms of their convergence. So that's root k squared plus 4 over k if I reduce. The 4 doesn't matter. The square root of k squared is k. K is always positive. And so that's 1, and the limit of 1 is 1. So it's a finite value, which means that this diverges, so this does the same. Since the limit as k goes to infinity of one over the other is a finite value, And since diverges, it's the harmonic series, therefore, by the limit comparison test, my original series diverges.